Welcome back. Today we are going to see queues, and this is going to be the last topic in your second unit. Uh, so when we talk about queues we can find everywhere in our day-to-day life, right? So if you take queue in DS, we say that it's an ordered list in which insertion and deletion takes place at different ends. When we were talking about stacks, I told insertion and deletion is done from the same end, and stack follows last in, first out. That was something like a stack. But in case of queues, the insertion and deletion is done from the different end. So from where elements are added, we call it as rear end or rear end. From where deletion is done, we call it as the front end. So please remember, every queue is having two ends, the front end and the rear end. Front end is the one where the deletion happens, and rear end is the one where the insertion happens. And queue always follows first in, first out. Everywhere you can see these queues in railway stations, bus stations, every place you can find queues. Nowadays everything is virtual, online shopping, other things are there, but otherwise if you take you could find these queues in our day-to-day life. And queues always follow first in, first out, which is nothing but first come, first serve. And deletion is done from the front end, and insertion done from the rear end. So please remember, queue is having two ends, but in case of stack we have a single end, right? Yeah. So if you look at the diagram, look at the first one. We have a single alphabet, single character, which is A, and look at F and R. R is the place, or R is a pointer which will point towards the last element in the queue. Front will be always pointing towards the front end, which is nothing but the first character in the queue. Look at the next one. We have got two characters A and B. Look at F and look at R. Look at the third diagram where we have three characters. R has got incremented, but F remained as it is. If you go to the next one, we have inserted one more character D, and look at R. R has changed its position and F remained as it is. To go to the next diagram, we have inserted one more character which is E, and R is a pointer to the last character, and the front end or F remain as it is. And the very interesting is the last diagram. Look at that, where we have changed or we have deleted the first character. Deletion is done, and F got displaced, F got changed. Now F is a pointer to the B, and which is going to be the first character in the given. So please remember, two variables, two important terminologies, which is friend and other one is rear. So friend is a queue friend, and R is something but the queue rear, right? So if you look at another example, there is another one. So we have represented this queue in the form of an array with size as 5. And if you look at the first one, we have a single character A, and front and rear is pointing towards the same index value 0. Come to the next one, where we have inserted this one more character which is B, and look at F and look at R. F remain as it is and its value is 0, and R has changed its value from 0 to 1. Look at the next diagram. We have inserted one more character which is C, and F remain as it is, and R has changed its value from 1 to 2. Look at the next diagram, which is we have inserted another character D, and R changed its value from 2 to 3, and F remain as it is. If you go to the next diagram, R takes value 4 and F remain as it is. And if you look at the last diagram, it's very important. F has changed its value because there is a deletion happened in the queue. The deletion always takes place from the front end and insertion done from the rear end. So when deletion is done, there is no changes with R value, so only change happens with F. The same way, when insertion happens, there is no changes with F, only change happens with the R value, right? So what next is about the queue operations. So what we can do with the queues? So normally we have to create a queue creation. So look at the things. So we have taken a variable called max queue size. It's a variable. So we have defined it as 100. Then we have taken a structure typed up struct and with a single parameter. And look at the element after the brace. So what has done? We have created a new type called element. It's something like your integer, float, and character. You have successfully created a new data type. Now, if you look at the next statement, we can find element q max q size. Look at that element q max q size. So what does it mean? You have created an array. What is array name? Array name is q. And what is the size for that? Size for that is max q size, which you have defined already, and the size is going to be 100. And what type of array it is? Is it an integer array? No. Is it a character array? No. Is it a floating point array? No. It's an array of element. What is element? Element is a type which you have created, user have defined. User has created its or his own type, that is element. Now what we do is we are going to initialize the front and rear is equal to -1, because if it is 0, which is going to give the starting address of the array, so we are not taking it. So we are going to take it as rear and front is equal to -1. So we have successfully created a queue with the value -1 for the front and rear variable. Next is you have to check the queue is empty or what. So when can I see that the queue is empty? When the front is equal to rear value, I can say that the queue is empty. If you take the previous case, if you take the starting case, we just created an empty queue where the rear and front value is equal to -1. Look at is full. I should say that I should check it out before insertion whether the queue is full or what. How could I say that? When the rear is equal to max queue size -1. To take this case, we have taken the max queue size as 100. So if my rear value is equal to 100 minus 1, which is going to be 99, what does it mean? The queue is full because the queue's index value starts from 0 because we have taken an array for this. If it is more than that, we cannot insert any element. So this is the many for this. So we have successfully created a queue. We have checked whether it is empty or what. Then we have checked it is full or what. If it is done, next is the add item. So insertion and deletion is very simple. So before I insert an element, I'll check it out whether rear is equal to max queue size -1. If it is true, I'm going to call the function queueful. Otherwise, what I do, I'll just increment rear, increment it, and insert the item. We're done with this. For deletion, I have to check is there any element left out in the queue or what. If it is empty, I'm just going to call queue empty. Front is equal to rear. Otherwise, what I do is I'll increment front. In fact, I cannot delete it. I'll just see that my front end will point to the next element in the front, and I'll return it. So this element will be returned to the calling function. So we have successfully completed all the operations in the queue, right from creation till the deletion. So this is about the queue operations.